Good morning, everybody. How's everybody feeling by now? All right. Has everybody had a good conference? All right. Hopefully there's still a little more room in your heads. So we have a lot of exciting things to share with you. Before we get started, just so you know, the handout for this session you'll find at my website. And so what you want to do is start at tammywooster.com, and then once you load the page, if you look across the top, you'll see several tabs. You can click the one that says Training Handouts, and then you'll see a link to ISTE 2013. Now, unfortunately, somehow, about 10 minutes ago, I deleted this entire page, which had all of my handouts for all of my sessions in it, and so I will get it back soon, but for now, I just have the link to this session, which is the one that you really need for now anyway. And you really don't need to go here right now. It will just be there for you to refer to later if you want to. So even though my website is still tammywooster.com, there has been sort of a change in the last year with not necessarily my website, but with about everything else in my life. And it's a fun little story. Last August, I think it was the first day of August, I was asked to come in and do some training near Nashville, and it was a group called SDE, and they were bringing in presenters from all across the nation, and to save a little bit of money, they asked us to share rental cars with each other. So I got this memo saying, you know, you're supposed to get there first, and then 45 minutes later, you're going to pick up this other presenter at the airport. And so I Googled who I was picking up, and it was like, okay, you know, it's a man, so I wasn't real excited about that. And he was a math guy, and so I thought, oh, here I have to spend 2 days with this guy I don't even know. And to make a long story short, 3 months later we were married. And so, yep, married to a guy that I picked up at the airport, literally. So my name now is officially Tammy Tang, but I haven't quite made the transition yet in my business life. But I do want to introduce my husband, Greg Tang. And yes, isn't it a great story? And so I'm going to let Greg take over, and he's going to share some things first, and then I will come back up and share some web resources, and then we'll let him finish up the day. But I think once he starts talking, you probably won't even want me to jump in and take over, but I'll try to sneak in and share a few things. So, Greg, I'm going to turn it back to you.
Thank you, Tammy. So here's what I'm going to do. I'm going to see, because the new kind of what's on the future for math education, we got the Common Core in a lot of the states. In Texas, we don't. But your own standards are probably just as rigorous as the Common Core. The whole idea of the new standards is to get kids ready for math when they're older, when it really matters, high school, college, and beyond. And to do that, it's going to take a different kind of mindset in order to get the kids ready. Now, in the old days, if you're an elementary teacher, a lot of times we'd say, oh, kids got to know their math facts. Does a kid have to know their math facts? Yes or no? Yes. Which ones? All of them. That's the problem. You got to know all of them. We tend to say, oh, you got to know these. You got to know your times tables. But your times tables only go up to 12. When you get to middle school and high school, what's going to happen to the numbers? They get a lot bigger and they get a lot smaller, decimals and fractions. So the question is, can we get a kid ready for all numbers? Can we get a kid ready for math when math is more difficult? And when you start to think like that, the challenge is really great. Now, I'm going to use multiplication as an example of how, when you teach a different way, when you get away from this idea of memorization, but really focus on how numbers work. And the other important key is, can you get kids to become smarter? Now, everybody has smart kids in their class. Those kids you don't worry about as much. Okay, the kids that you worry about, the ones that need help, are the ones who are not good at taking what they know and applying it. Smart kids, smart people are good at taking what they know and applying it. That's what makes them smart. So the question is, could we change our teaching to really focus on connecting things, connecting concepts? So here's an example. Here's the first question. So if I said to you, do you know how to multiply by 5? Yes or no? Well, you better say yes. Ready? Answer as quickly as you can. Ready? 5 times 3. Now, when I work with kids, you know how I want them to answer? 15. Ready? 5 times 5. 5 times 6. 5 times 66. Now, does anybody know the answer? 330. Who said 330? Nerd. Now, it turns out, the question 5 times 66, it wasn't, do you know 5 times 66? Back up a little bit. My question was, do you know how to multiply by 5? And when you said yes, what were you thinking I was going to ask? Was it 5 times any number or 5 times up to 12? And that's the mindset we got to change. When we say we're going to teach a kid to multiply by 5, no, we got to get them ready for 5 times any number. How do most kids multiply by 5? They skip count. Is that going to work with small numbers? Yes. Is that going to work with big numbers? No. So what do we do instead? We teach kids ways to think about numbers that make them easier. Then later we're going to see, can we use technology to give kids the repetition, the practice, to get them great with numbers? Okay, so what it starts with is not the technology, it's are they thinking about numbers the right way? So when I ask a kid to find 5 of something, you know what I do? I don't ask them to start with 5. I ask them to start with 10. Now, if I want 5 66s, would it be easier to start with 10 66s? Yeah, because if I ask anybody what's 10 times 66, they're going to know the answer is 660. Well, if you start with 10 and you only really want 5, what are you going to do to the 10? You're going to cut it in half, right? So a group of 5 you'll find with ease, half of 10 is just a breeze. Start with 10, cut in half, that's your 5. Ready? What's 10 times 66? 660. Cut 660 in half, and what do you get? 330. Now, that's not a new strategy. Okay? I would bet 90% of the people in this room know that strategy, but don't use it. They don't use it when they multiply by 5. When do they use that strategy? When they go to a restaurant and they figure out a 15% tip. Okay, if I said the bill's $66, you want to leave a 15% tip, then what do? You do 10% and 5%. Well, how do you get the 5%? Half of the 10%. So we say, oh, I got this trick for the 15% tip. The key is, do you apply that everywhere you can? Well, when you multiply by 5, start with 10, cut in half. Here's the next one. Ready? 5 times 88. What's 10 times 88? 880. Cut that in half. What do you get? 440. Now, I haven't been writing things down because one of the things I'm trying to push teachers to do is to get kids good at mental math. So when I design games, online games and apps, a big part of what I'm trying to do is develop mental math skills. Okay? So, do a lot of people find math easier to do when you write it down? Yes. So if I was working with kids, I would write things down at the beginning, and then I would stop. Okay? So let's do one more. I'll write it down in case you're having trouble with the mental math. Ready? 5 times 42. What's 10 times 42? 420. Cut that in half. What do you get? 210. Raise your hand if you've ever taught a kid to multiply by 5 by skip counting. Okay, you have to do it that way. Ready? All you skip counters. Ready? 5 times 86. Start skip counting. Go. Now, what's 10 of those? 860. Cut in half. What do you get? 430. Has everybody got it? Okay, it's time for your assessment. Ready? Here's the deal. If you can answer it correctly in less than 2 seconds, you get a free book. ISTE will send you a free book, not me. Ready? Here we go. Got to answer correctly less than 2 seconds. All you got to do is take the number, multiply by 10, cut it in half. Yell out the answer less than 2 seconds. ISTE will send you a free book. Ready? 5 times 79. Go. Raise your hand if you said 345. No. What's 345 doubled? It's actually 690. Okay, now I said 5 times 79. Was I pretty confident nobody was winning a free book? I was very confident. Okay, what's 10 of those? 790. When people look at 790, they got to cut that in half. Is that an easy number to cut in half? No. What's the number one strategy people use if you give them a hard number? No, they stare at it. Okay, so most people stare at it. Okay, and they're like, oh, that's a hard number. Okay, and then you know what they're thinking 5 seconds later? That's a hard number. Now, here's what I'm going to teach a kid to do. I'm going to teach a kid no matter what the operation, no matter what the situation, whenever something's too big, you break it apart. You make it more manageable. How do you teach a kid to read a big word? You break it apart. Ready? Think of the 790 as a 700 and a 90. Quick, what's half of the 700? 350. What's half of the 90? 45. What's the answer? 395. Okay, which is easier to work with, the whole or the parts? The parts. That's why we break numbers into parts. Okay, now, same trick to multiplication is the same trick for division, addition, and subtraction. It's always the same trick. Okay, so let's do one more. Ready? I'm going to ask you to cut this number in half. Go. What would I hope you're doing to that number? Not staring at it. Ready? What's half of the 900? 450. What's half of the 30? 15. What's the answer? 465. Has everybody got it? Go. So now I teach this kid this trick. They're like, oh, I know the trick. And they're thinking to themselves, oh, now I'm good in math. They learned one trick. They can divide by 2. Does that make them good in math? No, but the kid's all happy with himself. Oh, I can divide by 2. They have to be able to take this concept, this idea, and apply it. So my teaching is focused on teaching kids to apply what they know. Okay, I want to give them more knowledge, but I also want to take everything they know and teach them to apply it. Okay, so everybody knows the trick to divide by 2? Here's your assessment. I'm going to give you a bigger number. I'm going to see what you do with it. Ready? 91 divided by 7. Go. How many of you are staring at that number? A lot. Ready? Here's all you do. Ready? Is that easy to divide by 7? No. What number is easy to divide by 7? 70. If you thought of that as 70, well, what's the other part? 21. You look at that problem. Is that easy to do? That's easy to do. That's 10. That's 3. The answer is 13. Okay, so what we're going to do is teach kids to apply what they know. Ready? Last one. Triple-digit number, divide it by a double-digit number. Okay, let's see what you do. 192 divided by 16. That's not easy to divide by 16. What number is easy to divide by 16? 160. What's the other part? 32. Is it an easy problem now? The answer is 12. Okay, that's what we can do with math. Okay, what's the trick in both of these? You think in groups of 10. So we're a base 10 number system. We teach kids to think in groups of 10. Does it always work to think in groups of 10? No. That's the problem. So you need more of these strategies. Ready? Here's the next one. 128 divided by 16. Now, you know what most people are thinking? Oh, that's a hard number. Now, watch this. I'm going to rewrite this as a fraction. Now, what do we teach kids to do with fractions when the numbers are too big? We say simplify, reduce. Ready? What's half of 128? 64. What's half of 16? 8. Quick, what's the answer? 8. Now, here's the point. If you're allowed to reduce a fraction, and this division problem has the exact same meaning, are you allowed to reduce a division problem? The answer is yes. Ready? What's half of 128? 64. What's half of 16? 8. Quick, what's the answer? 8. So there's so many ways to think about numbers that make them easier. So if you think you're bad in math, maybe the problem, or when a kid thinks they're bad in math, the problem is nobody took the time to teach them how numbers work. So that's what we're going to do. We can design games that teach kids the right strategies, then give them the repetition and practice they need to get fluency. Okay, so what have we done so far? What's the secret to multiplying by 5? You start with 10 and you cut it in half. Now, if I teach in a way to develop the kid's ability to see patterns, it's a lot easier to do my teaching. Are kids good at looking for patterns? They are. That's what people do. Your brain automatically looks for patterns. Ready? I told a kid 5 is half of 10. Maybe they didn't think of that on their own, but I showed that to them. Now I'm going to say to a kid, well, let's multiply by 9. You want 9 of something. If I said 9/8 and I show you 9/8, quick, what are you thinking instead of adding 9/8 together? Start with 10/8, right? Wouldn't 10/8 be easier? Now, when you look at those 9/8, could you tell quickly there were 9/8? Yeah, I hope so. You know what I did? If I had written those 9/8 in a row like this, quick, are those 9/8? No, there's only 8 of them. The point is, when I write them out like this, is it hard to tell how many? Notice I wrote them as what? 10 frame. Okay, 10 frames are so important because it allows you to process information quickly. So everything we do is based on how do you show things, how do you think in the right groups. Now, 9/8 is hard. Quick, what are 10/8? 80. What's 80 minus the extra 8 since I only want 9? 72. That's how I want a kid to think about 9. 9 is 1 less than 10. 5 is half of 10. Okay, is it really the same trick? You start with 10 and then you do what? You make an adjustment. Now, if I teach like this, kids are going to figure out the tricks for themselves. Now, let's do one more. 9 times, what are you going to start with? 10. Subtract the extra one. A group of 9 requires tact. Start with 10 and then subtract. That's all I do. Ready? 9 times 45. Everybody, what's 10 times 45? 450. What do you have to subtract? 45. That's 10 45s. I only want 9 45s. I subtract the extra 45. Do you have to worry about the 400? No. What's the difference between a 50 and a 45? 5. So what's the answer? 405. One more. 9 56s. What's 10 of those? 560. What do I need to subtract? The extra 56. Do you have to worry about the 500? What's the difference between a 60 and a 56? 4. So what's the answer? 504. Now, was this reasonably easy to do when I wrote it all out and you can see it? So you know what I'm going to stop doing? Writing it out. I'm going to develop mental math skills in my students. Ready? 9 times 67. What's 10 of those? 670. What do you have to subtract? 67. What's 670 minus 67? 603. One more. 9 times 78. This time I'm not going to help you at all. Raise your hand when you have the answer. Don't say it. You can raise your hand if you don't have the answer. I'm not going to call on you. Everybody, what's the answer? 702. Raise your hand if you got 702. Raise your hand if you're surprised you got 702. Raise your hand if you're getting some weird sense of satisfaction. Okay, we can get all the kids to be good in math. It's just how we teach them. Now, so what have we seen so far? 5 is half of 10. What's 9? 1 less than 10. If I said, okay, what's 11 times a number? What are you thinking? 1 more than 10. Okay, the way I teach gets me to where I want you to go. Okay, now, if I say to first grader, I've done this many times. I go to first grade class. I say, okay, we're going to learn to multiply. They just stare at me. Okay, the kid's only like 6. So I go, what's 11 times 3? They stare at me. They don't know what I'm talking about. I go, it's 33. And I'm waiting, nothing. Okay, so then I go, what's 11 times 4? Kid stares at me. I go, it's 44. The minute I say 44, does their face change? It does. Do they have any idea what I'm talking about? No. Okay? But their face changes. So then I go, what's 11 times 5? The kid will go, 55? They'll ask me. And I'll be like, yep, you are so smart. Are they all happy with themselves? Yes. Do they know what I'm talking about? No idea. So then I'll go, quick, what's 11 times 6? This time they don't ask me. They'll go, 66. And I'll go, you are so smart. And they're all happy. So then I'll go, quick, what's 11 times 7? They'll go, 77. I'll go faster. I'll go, quick, what's 11 times 8? They'll go, 88. I'll go, what's 11 times 9? They'll go, 99. I'll go, quick, what's 11 times 72? They'll go, 72, 72. Now, here's the point. Did the kid get a lot of these right? Do they have any idea what I'm talking about? Nope. That's what happens with math a lot. If you get a right answer, people are happy with you. You have no idea what the person's even asking you. Now, the point is, we don't teach kids to look for patterns. We're trying to teach kids to understand why patterns are patterns. It's the concept underneath the pattern that's everything. That's what we're going to focus on teaching. Okay? So, if I said to you, okay, ready? Look for the pattern. Ready? 11 times 72, here's the answer, 792. Ready? 11 times 81, here's the answer, 891. One more. 11 times 36, here's the answer, 396. Does everybody see the pattern? Okay, say the next one with me. Ready? 11 times 45, what's the answer? 495. Does everybody see the pattern? One more. 11 times 18, what's the answer? 198. Has everybody got it? Okay, this time here's your assessment. Say it as loud as possible. Ready? 11 times 33. What's the answer? 363. Raise your hand if you said 9. Okay, here's the point. Was I trying to trick you into thinking there's a 9 in the middle? Is there always a 9 in the middle? No. Why is that one a 9? 7 and 2 is 9. Why is that one a 9? 8 and 1 is 9. Why is that one a 6? 3 and 3 is 6. Okay, do one more easy one. Now you got it. What's 11 times 41? 451. You just add those two numbers together and stick it in the middle. Okay, now, should a kid memorize their 11s table up to 100, or should they understand how 11s work? Understand how they work. How does an 11 work? Well, it's really what? 10 and a 1. Okay, let's break it apart. What's one of those 41s? 41. What's 10 of those? 410. There's the 4 and the 1 you started with. Look what goes in the middle. 4 plus 1 is 5. Has everybody got it? Okay, one more. 11 times 32. Everybody, what's the answer? 352. Has everybody got it? Ready for your assessment? Okay, as fast as you can, yell out the answer. Ready? 11 times 66. Go. 6,126. 6 plus 6 is 12. I stick it in the middle. Is that the right answer? No. What do you have to do to the 1? You got to carry it. It's 726. So when numbers get harder, does math get a little bit harder? Yeah, it does. That's why kids really have to understand what they're doing. So everybody got the trick? I'll do one more just to make sure you got it. If I said 11 times 77, what would the answer be? Be 714.7, which is really what? 847. Is everybody good with that? Okay, here's your assessment. Now, people are always saying to me, Greg, you talk too fast. You're always rushing us. Okay, so I say, okay, there comes a point in every class where you're trying to build what in your students? False self-esteem. Ready? Here we go. 11 times. I'm going to write down a problem. I'm going to let you take 10 seconds to look at it. Study it. Ready? When I say go, yell out the answer. See, I'm not rushing you. Has everybody got it? Ready? Just yell out the answer. Ready? Go. Now, here's the point. If I teach a kid a trick that only works for double-digit numbers, is that a good trick? That's a bad trick. Here's the answer. 3795. Does everybody see where the 3 came from? Right there. Where'd I get the 7? 3 and the 4. Where'd I get the 9? 4 and the 5. Where'd I get the 5? From the 5. Does this always work? Yes, because an 11 is always a 10 and a 1. So if you even said 11 times 327,154, would we know the answer? What's the first digit? 3. Next then, 5, 9, 8, 6, 9, 4. 3,598,694. Okay, so again, this is a trick. It's special to 11 because 11 is a special number. It's a 10 and a 1. But you know what's behind every single great trick somebody's going to show you in math? There's a clever way to take a number and break it apart. That's really what this is all about. So I've designed tons of materials online, games, that teach kids to break numbers apart in smart ways. Last trick, and I'll turn it over to Tammy. Ready? Subtraction. Kids good in subtraction? Actually, they're not. What's the worst subtraction problem they're going to face? The kind they hate. Zeros. Okay? When I go 800 minus 347, everybody think about how you would solve that problem. Okay, here's what they taught us. Ready? Go to the ones place. Oh, there aren't any. Oh, all you have to do is go to the tens place. You go to the tens place. There aren't any. You have to go all the way to the hundredths place. Cross this out, make it a 7, cross this out, make it a 10, cross this out, make it a 9, cross this out, make it a 10. Okay, did I even do that right? No. Did I? No. Did I? See, you don't even know. Did I do that right? Yes. No. See, you don't know. Now, turns out I did do it right, but it confuses me. So, you know what new math says? It says take the 347, don't regroup. Take away the 347 in parts. What's 800 minus the 300? 500. What's 500 minus the 40? 460. What's 460 minus the 7? 453. Wasn't that easy? No, a lot of people can't do all that in their head. So you know what you do instead? Instead of breaking the 347 into 3 parts, just break it into 2 parts. Ready? What am I going to take away first instead of the 300? 1. I'm going to think of 347 as a 1 and a 346. Does 1 and 346 make 347? Yeah, so I'm just breaking it apart. Now let's subtract in parts. Ready? What's 800 minus 1? 799. Now take away the other part, 346. Quick, what's the answer? You can just look at it, 453. What did I just do to a difficult regrouping problem? I just made it easier. Okay, these 2 problems have the same difference. This one's easier to calculate. Okay, another way to look at this problem is, if here's an 800 and here's 347 on a number line, I'm trying to figure out the difference. Look what I actually did. I took away 1 from the 800, and I got 799. I took away 1 from the 347, and I got 346. What can you say about the new difference compared to the old difference? It's the same difference. I just shifted the difference. So the more you start looking at math and tricks and strategies, you know what you find out about all of them? It's the same trick. The trick is you take a number and you learn to break it apart the right way. And if we can teach that to kids through games, through technology, we can actually make it fun and interesting. Then we design games in a way that they're actually engaging, they're challenging, and it's not about shooting things or finding things or doing non-math activities. It's about doing math. And if we can do that, we have a chance to completely change the way kids are learning math. Okay, so I'm going to turn this over now to Tammy. She's going to run through a couple apps with you, things that are kind of fun to do in math. Thank you.
Isn't he awesome? Yeah. So what I'm going to do is just to share some of my favorite technology resources that sort of feed into some of the things that Greg was talking about. One of the things that Greg is really good at is going into classrooms and making math fun for kids. And so I think we need to keep in mind that sometimes kids have the mindset that math can never be fun, you can never do anything creative with it. And one of the things that I'm passionate about is using technology, and I love Google tools, even though I'm not paid by Google or they don't sponsor me at all, but I love their tools. And so one of the activities that I wanted to show you, and does everybody have a device that they can get online with? Do some of you? All right, if you do, get them out and ready. And this is just a little activity that is already set up. And one of my goals is to create a lot of these types of templates that are aligned with the Common Core standards, and Greg is going to help me to do this. And so this one involves possibly estimation and measurement. And the scenario is, and this is all done for you, in the handout you'll find a link to it. So this is what you'll find in the handout. The activity is how tall are we? And the link says go to this page, and that will take you to the page that looks exactly like this. Then on this page I have the instructions for you, and what we would do with our class is to imagine if we were all to make a tower and stand on each other's heads, how tall would we be? So at that point you could have your students estimate and think about, well, would we be taller than this classroom? Probably. What if we went outside? Would we be taller than the entire school? And so you can have them sort of try to picture that in their heads to begin with. Then this is done through a Google spreadsheet and form. And so what it tells you to do, first of all, is to go to the form menu and pull down to go to live form. And that's going to take you to the form that you're going to use to have the students enter their height. Then at this point, what you'll want to do is to either take the address at the top of this page, or if you want, you could make the address a little bit shorter first. So has everybody been in one of my other sessions to see this handy little Chrome extension? This is a great extension that doesn't really have anything to do with this presentation, but if you have Google Chrome, look for the Shorten Me add-on, and it will automatically create a QR code and give you a shortened link to whatever web page you're on. And so I'm just going to copy this address because I also have it set up in my template that as soon as you paste in the address for the form, it's automatically going to create the QR code for you. So now what I need you guys to do, and we'll see if I can align this so that you can see both, is to either scan this QR code, which should take you out to the form, or type in the address, and it's goo.gl/2VU, I believe it's O and then a 0. Is that what it looks like? And it is case sensitive, so you have to be a little bit careful typing it in. Is anybody getting the code to scan? Yes? Okay, good to hear. And so what I need you to do is to put in your first name and then put your height in inches. I don't want feet in inches. I don't even want any labels with it. I want just numbers only. So just put in your height in inches. By the way, if you're typing in the address, make sure you type it in the address bar and not in the Google search bar of whatever browser you're in. And you don't even need the HTTP. You can just start with the goo.gl/2VU00. Did you get it? Let's see if I can move it over just a tiny bit more. Well, there, see if you can scan it now. All right. Okay, very good. So raise your hand if you got into the form. All right, so it looks like we have quite a few of us. Now, this is a rather large group, so imagine if everybody that's online in here were able to stand on each other's heads. That would be quite a lot. Now, if you were able to fill it out, but the person beside you can't, you could hit the back button and then you could enter theirs for them. So find out, somebody sitting next to you, find out how tall they are, and then enter them as well. So what's happening is that, oh, and by the way, I should point out that you all and your students do not need to have Google accounts to fill out a form. Anybody can fill one out. And so the teacher would need to have an account in order to access this document. But most of you have Google accounts already, right? So you'll be able to get to this, but your students will not need accounts. So what's happening now is, as you fill this out, it is feeding your responses into the spreadsheet, which is on another sheet, and we'll see if we can get it to load here. It's acting a little bit sluggish. So if I go to the form response sheet, then we see all of your heights coming in here. And all right, this one I'm going to, I think that says 5'6", so that would be 66 inches, right? So I'm just going to quickly look through and make sure it looks like all the data is pretty standardized. This one I'm going to get rid of the label because I need numbers only here. All right, we have some decimals there. That's all right. 5'10", you guys help me out. 70. All right, we have somebody really tall out there. 5'2". 67, I need to just get rid of the inches. So, all right, so we have almost 150 of us now standing on each other's heads. So how high do you think we're going to be all together? Anybody have any idea? Well, if I just click now, down at the bottom, there's the Start Here button, there's the Form Response button, and then there's a button that says Chart. And so when I click here, it is going to show us. So our class, all together, if we stood on each other's heads, would be 832 feet high. And then the chart over at the right-hand side compares our class to other places. And so generally with a class of about 25 people, you're about as high as the water tower. And so what you could do at that point is to involve a little bit of research. You could ask the students, you know, let's invite some more people into our tower. What if we wanted to invite maybe U.S. presidents? So choose a president that you like and go and find out how tall they are and then enter them into the form. And the students can keep filling it out, and you can have them keep going out and doing a little bit of research. You could have them pick the tallest person they know and add them to our tower. And so then we can see how high we can get our tower by adding additional people. So it's already done for you as a template, and like I said, I'm working on creating some more of these, and I will index those on my website once I get some more created. If you guys have any ideas for some, be sure to let me know. So one of the things that Greg talks about a lot is getting students from doing everything concretely to moving to abstract thinking. And so some of my favorite websites for doing that, one that I really love, and it is a very long address. It's part of the Glencoe site, and I'm not really sure who shared this with me initially, but I have a feeling that maybe you're supposed to buy their textbooks before you have access to this site. So I sort of sneaked in some way. I can't go back to the Glencoe original site and find my way here. So you have to go to this really long address. But I have a link to it on the handout. So you'll be able to click this long link, and then that will get you there. And I think it's a very fabulous site. If any of you have a smartboard or interactive whiteboard, it works with it. And what you can do is to go in and select your grade level, and it goes from everywhere from pre-K through 8th grade. But even if you taught high school math, I think you would be able to use the 8th grade ones probably with high school. I'm just going to select kindergarten because I think theirs are really cute and they're fun to show. But in this area, you have all sorts of game boards you can choose from. And so when you mouse over them, it shows you what the game board is going to look like, and then that game board would load on the screen, and then you can move things around it if you wanted to. There are tons of different storyboards that you can use. And so we have baseball diamonds, we have blank calendars, we have the box 10 frames, so all sorts of different storyboards or backgrounds. And then there's a series of work mats that you can choose. And here we have like the 10 frames and then 2 10 frames and all of those. And then the third option is where you get the manipulatives. So now we have all the manipulatives that you normally have in tubs in your classroom, and they're all online here. So we have the attribute blocks, we have the calendar, counters, fraction circles, geoboards, all of those things are here. So even though these seem somewhat concrete, they're more abstract because the kids aren't actually holding them in their hands. So I think it's a good bridge between the concrete manipulatives and moving to more abstract thinking. So I'm just going to quickly show you bears in a boat because I think it's very cute and fun to show. So you can just grab things and drag them over onto the screen. And again, if I were connected to a smartboard, I could just drag them over from there. Then you can grab the bears and you can put them in a boat. So you could work through some different scenarios with young kids. Notice how they sit down when you move them into the boat. Isn't that cute? And so if we had 2 bears in the boat and 1 more bear joins them, then we have a total of 3. But then if one falls overboard, now we're back to 2. So you can do a lot of cute things with that. I can clear that if I want. And then if we went back to the standing on their heads theme here, how tall would 3 bears be if they were standing on each other's heads? And this tool also gives you a lot of different measurement options. So I can click the ruler at the bottom. I can easily move it around wherever I want. I can rotate it. And it even becomes transparent so that I can move it right over the bears and line it up. And I can quickly and easily see that 3 bears standing on each other's heads would be 4 inches. And if I want metric instead, I can switch to that. So I think it's a pretty awesome site. Another website that is very nice is Illuminations. And it is partly sponsored by NCTM. And the activities are aligned with the national math standards. So again, this is a good example of an activity that can help students transition from concrete to abstract. So what it does is that it puts a certain number of bubbles, I guess they are, out, and then it hides them. So the student can't physically point to them and count them. They have to sort of remember the number in their head, and then they have to think about what was there, and now we have to think about what was left. And so it leads them to that more abstract thinking. And so Illuminations has a lot of really nice resources like this. Another one that I like is WorksheetWorks.com. And Greg talked about the importance of having students develop math fluency and doing lots and lots of practice. And this is a website that's been around for quite a while. It's been in beta version as long as I've known it. And I'm a little bit worried that when it comes out of beta, it may not be free anymore. But at this point, it still is. And it has all sorts of skill sheets that you can create for your students on the fly. So if you have a student that needs just some extra practice with basic math skills, for example, you can go into this area. And the students, of course, could use these to practice some of the strategies that Greg talked about earlier. So if I needed help with division, for example, I can choose division, and then as a teacher, you get to choose from all the different types of division skills you want the students to look at. So maybe I just want some basic division skills, and then maybe I only want them to practice dividing by 5s so that they could practice that strategy that Greg showed earlier. So I can say, okay, I only want to practice dividing by 5. I can choose the range of dividends and make it the size that I want, and I can decide whether I want horizontal or vertical problems, how large I want the font size to be, and then I click the Create Worksheet button, and just like that, it creates a PDF document for me that has the problems that I asked for. So now we have a whole page of practicing dividing by 5, and we also have the answer key that goes along with it. Now, I know that we're working towards a paperless classroom, so one thing that you could do is that if you just had this showing on your smartboard, students could go up and write in the answers to the top half of the page, and then you could just scroll up and get them to match, and then you would be able to check and make sure they got them right. So you could either print it or you could do it paperlessly if you wanted to. One other website that I really like is mathplayground.com. And Math Playground is created by a teacher, and there are a series of different games and activities there. There are also a lot of videos that the teacher has recorded of how to do different concepts. But one of my favorite games, although I hesitate to try to play it in front of people, is Weigh the Wang Doodles. And this is a great one for higher level thinking and pre-algebra skills. So what you're supposed to do here is to figure out how much each of the Wang Doodles weighs. And it's telling me that green plus blue equals 26, red plus green equals 22, and blue plus red equals 34. So what I do is that I come down and move the sliders. So the students could do this by guessing and checking. So I know that it looks like the green one is pretty little, so maybe I'm going to say that maybe the green one might be, let's say 8. So then if the green one is 8, then what would the blue one have to be to equal 26? Okay, 16, so we could try that. And then if the green one is 8 and the red plus the green equals 22, then what would the red one need to be?
Blue's got to be 18.
Okay, so Greg's already figured it out over here. And so Greg says blue has to be 18?
No, you just made a math mistake on the last one.
Oh. So tell me what I need to change.
That needs to be 18.
This one needs to be 18. Okay. So 18 and 8, 18 and 8 is 26. Sorry about that. And then 8 and 14 would be 22. And then we'll click check it and see, and it says none of the Wang Doodles have the right weight. So the students then keep adjusting these. So anybody figured it out? I don't know. I can do it really well when nobody's watching, but under pressure I can't do it, so that's my excuse. So you can see that it's a little bit challenging, right? And so you keep adjusting them until you get them to be the right weights. And the students love this. It's a great challenge for them, and I'm going to move away from it before I embarrass myself any further. You guys can go out and try it on your own. So that, again, was part of Math Playground. I'll take you back to the original site so that you can see what it looks like. And she has lots of different math games and logic games here. And then the math videos that she provides are, I think she recorded them on a smartboard maybe. And sometimes it's good, maybe you explain something and the kids aren't quite getting it. So sometimes it's a good idea to let somebody else explain it, and maybe they will explain it in a way that makes a little bit more sense. So you might want to check that out. So my very, very favorite math website, believe it or not, is this one. And this is actually Greg's site. And the really awesome thing about Greg's site is that as of June 1st, 26 days ago, this site became free. Up to that point, it was hosted on Scholastic's website, and you had to have a subscription for students, and they had to pay, and they had to have logins in order to get to it. But now it's all available for free. So how many of you are familiar with Greg's books? Yeah, Greg has a series of books. You're probably familiar with them: The Grapes of Math, Masterpieces, Math Appeal, Math Potatoes. Those are all books that he wrote, and they are all online for free at his website now. So you can go into any of, yes, isn't that awesome? Yay. So you can go into any book, and all of the pages are there, and they're animated. So this one, for example, how how many dots do you see there on the dice? Not how many dice, but how many dots do you see? So figure as quickly as you can how many you see there. Okay, what strategies are you using to figure out how many are there? Are you saying 6 plus 6 is 12, I double that, that's 24, I add 2 more? Yeah, and so that's one strategy that might work, and students might have different ways. Some may just start counting them all together, but if you read the poem at the side, and especially the last 2 lines, it says, before you start, please look around, adding's fast when tens are found. And if we click the hint button at the bottom, it might help you out a little bit. So if you look across at each row, what do you see? Tens. And so how many are there altogether? And then you just enter the answer and click submit, and then it tells you if you're right or not. And so each page of the book is done like this, where it's all animated and it's interactive so that the students can get the hint and then they can enter their answer. So let's take a look at one from the Math Appeal book. In this one, how many squares do you see on the kite? Yeah, now there might be some different strategies here. You can see that there are 5 across the middle, and then perhaps you can combine other rows together to make groups of 5. So we could combine the 3 and the 2 to make 5. We can combine the 1 and the 4 to make 5. And so we might be able to quickly count up that way, right? Did anybody do it that way? Did anybody just start counting squares? Did you have another way? Okay, so he did 2 tens plus 5, so that would be a great strategy. But let's look at the poem at the side. My kite flies high, my kite flies free, my kite just landed in a tree. I was busy counting squares, now my kite is stuck up there. How many squares? Let me see. It's best to add diagonally. So now if I click the hint button, yeah, now what do you see? Yeah, now you see it in groups of 5, and so it's much easier. So it's just teaching the kids to look at numbers and look at patterns in a different way, as Greg has been pointing out. So awesome things in his books, and they're all free now online. Now, was it last summer, 2 summers ago, Greg hired his son to do the animations for this website. And Greg asked his son to do something fun with this so that the kids could click and do something additional. And so he asked him to animate the bird. So when you click the bird, it falls down. And so I don't know how I get back to show the other bird. Let me hit the back button here and see if I can get back to it. So the other bird, when you click it, then it falls off, and it rotates the other direction and falls off. So it falls off the other way, and kids love that type of thing. So Greg also has an entire series of games at his website that are really, really awesome and really get to what he was talking about earlier, practicing those skills of breaking things apart. And instead of me trying to explain it to you, I'm going to turn it back over to Greg and let him tell you about the games on his website, and then we'll let him finish up here. So we'll switch back over to him. Thank you.
Thank you, Tammy. Okay, the games I want to show, the one game I want to show, does anybody here play Kakuma? Okay, a handful of people. This is a puzzle I invented, and it's now an app. So it's available as an iPhone, iPad app. We're currently building the Android and Kindle Fire version. So we're finally switching the whole code base over so that we can write one set of code and it works on all devices. So that should be good in about a month. Okay, so I just saw the beta version. It works great. It's looking good. If I click on Kakuma, I have 4 versions: addition, negative numbers, multiplication tables, and fractions. Okay, so I'm going to click on addition. Let's just learn the rules. There are 10 levels of this game. So in the left panel, there's all the different versions. Let's pick an easy version just to learn the rules. So I'm going to click on 5 numbers. Now, here's how you play. In every group of numbers, there's only one number that's the sum of 2 other numbers. So if you look at the bold black puzzle, which number is the sum of 2 other numbers? 7. Notice 3 plus 4 is 7. I click on the 7. That's the answer. Let's go to the next bold black one. Which one's the sum? 6 plus 5 is 11. I click on it. Next one. 2 plus 4 is 6. Next one. 8 plus 4 is 12. Last one. 7 and 6 is 13. Are we done? No, those 5 numbers just made another puzzle. You're supposed to say that's really cool. It's pretty cool. Look, 7 and 6 is 13. So that's the final answer. Kid has to know their math facts. It gives them a time. We did it in 50 seconds. Okay, the record for a kid for that level puzzle is 3.3 seconds. Okay, so when you talk about fact fluency, I'm going to show you a video that redefines what we mean by fact fluency. Now, that was 5 numbers. That's like a kindergarten puzzle. There's only 5 numbers, and they were small. The biggest number was 15. If I click 6 numbers, the puzzle is going to be a little harder. If I click 7 numbers, it's harder yet. Let's do 9 numbers. Okay, this is for 3rd grade and up and adults. Okay, this time I'm going to ask you, don't say the answer. Raise your hand when you have it. Which number here is the sum of 2 other numbers? Okay, ready? 9 plus 12 is 21. Okay, let's do another one. Raise your hand when you have it. Now, if you don't see the answer yet, are you doing a whole lot of addition problems in your head? Okay, so I'm going to trick a kid into doing about 150 addition problems to do this one puzzle. Okay, so on this one, 10 plus 14 is 24. Okay, raise your hand on this one. This one's hard. Ready? 6 plus 4 is 10. Okay, here's the thing about these. They're so annoying, they're addicting. Say that again? I've never done that before, but let me try. Now, let's see. I wonder what happens. Okay, it turns out there's a clock running over here. So see, if I click, like here, the answer is 5 plus 4 is 9. I'm going to click on the 8. It adds time, a penalty time. Okay, so it's not going to let you click the wrong one. Here's the other good thing, though. If you need help, it's kind of hard with 9 numbers. If you click the hint button, notice how the numbers start dropping away. But every time you do it, adds 15 seconds to your time. Okay, so 5 plus 4 is 9. Let's just finish this up, and I want to show you a video. Next one. We're down here. In the back. Yeah. 15 plus 10 is 25. Very good. Next one. Are you guys enjoying this? Okay, ready? 8 plus 12 is 20. Next one. 10 and 13 is 23. 8 and 10 is 18. 5 and 3 is 8. And those 9 answers just make it another puzzle. What's the final answer? 10 and 8 is 18. Now, what you'll find about this is the average adult takes about 4 minutes to solve one puzzle. And then you'll get addicted because they really are annoying. Like, you can't believe you can't see the answer. But what happens is when you keep playing this, you end up doing thousands of computations in your head. And you know what ends up happening very quickly? You get really good with numbers. Okay, so after a couple weeks, you're down to a minute or 2. So I did 5,000 of these when I was developing it. I got it down to 16 seconds. So I'm thinking to myself, I am so smart. Okay, then I brought it to an elementary school, Title I, inner city school in Baltimore. The kids played for 1 month, 2 5th grade classes on iPads. This is an inner city Title I school. 1 month. Principal starts emailing at me. Greg, what's your best time? At that time, it was like 17 seconds. He's like, well, I got kids under 15 seconds. I'm like, they're cheating. I'm like, this is not possible. I said, I've done this 5 times. They're cheating. I said, you got to send me a video or I don't believe you. So he sends me a video. Now, I have a video I want to play for you. Kid got it down to 8 seconds. Okay, we got him on video doing it in 11 seconds. Then a week later, he did it in 8. Now, you picture seeing all those numbers. Now, when we did those puzzles, did some people once in a while, did you see the answer right away? right? They can see it every single time now because they've processed thousands and thousands of problems. Okay, here's James. Now, you'll never see his face. I'm telling you he's 11. Maybe he's 35. Okay? How do you know he's 11? Look at that chubby little hand over here. Okay? Your hand doesn't look like that. Look, there's no sunspots, no veins. Now, ready? I got him doing 11 seconds. Here he is. Watch this. All you do on iPad is you touch the answer. Just in 11 seconds. Those were his best times up until then. Okay, now again, this is an app, but you don't have, it's $1, but you don't need to pay for it. Online, if you go to gregtangmath.com, it's all free now. The best thing now is because everything's digital is I can level all the games. So not to make you feel bad, but the game we played, that was the easy version. Okay, the biggest number was 25. If you pick hard, they go up to 50. On the app, they go up to 99. So there is a level for every kid. The best part is, if you go to the other versions of Kakuma, okay, I can play the same game now with negative numbers. Okay, so if you teach 5th grade and up, how do you get a kid to practice with negative numbers? You never see them in your life, right? Well, you play Kakuma with negative numbers, we'll see quickly how hard it is to work with negatives. Now, I'm not going to pick 9 numbers because it'll make you feel bad. Okay? It makes me feel bad because I'm so slow. If I pick 6 numbers, same game, 2 numbers that add up to a third number, which one is the sum? So you look at these numbers, which one is the sum? Okay, 7 and a -3 is 4. The answer is 4. Next one. I've heard 6 and -6. If I click 6, it's not right. But -9 plus 3 is -6. That's the answer. Next one. This one's hard. Raise your hand if you've got it. This is really hard. It takes advanced math. Ready? 4 plus 1 is 5. Next one. -3 and -1 is -4. -8 and 5, -3. 5 and -2 is 3. Final answer. -6 plus 3 is -3. But all I'm trying to illustrate is you can't be good with negative numbers unless you practice with them. So I'm trying to develop games that will give kids practice. If I click on Kakuma, I play times. Now kids can practice their times tables. Okay, this one is actually much easier if you know your times tables. Let's click 9 numbers. This time, look for the product, not the sum. So in this group up here, which one is the product? 9 times 7 is 63. My computer just hung. Let's play it again. 9 numbers. Which one's the product? Here's a new one. 4 times 3 is 12. I click on the 12. One more. 18. 6 times 3 is 18, and so on. Okay, fractions. Let's click on Kakuma. Let's play the fraction version. Let's do 5 numbers just to make us feel better. Ready? Here. Same. It's an eye test for you older people like me. Ready? Which one is the sum? Notice they don't all have the same denominator. So you've got to find an equivalent fraction. What's the equivalent fraction for 1/5? 3/15. This one would be what? 6/15. 3/15 plus 3/15 is 6/15. That's a little harder. But again, I picked the harder level where it's asking for more equivalent fractions. I can pick the easier level, and there's at most 1 equivalent fraction. So again, the whole thing is leveled. And then if you click on games, there's 9 other games. The one I'm working on right now is called Subtraction. Okay, so what I'm going to do with that one, I'm really into the logos. I spend more time on the logos than the game. So here's my espresso game, because it's all about expressions. That took me about 3 months. Okay, I have funny numbers. Do you think that's funny? Should I lie and say I developed that one? That was my son's work. Okay, Subtraction, you know what the logo is going to be? A big tongue. Now, if you don't get that, you're too young. Okay? You're too young. Now, the other nice thing, if you're into math centers, we took all the games and we turned them into PDF files. So if you go to materials, worksheets, laminates, puzzles, and games. Laminates are all in color. Puzzles and games are black and white. So for instance, if you like Kakuma, you can click on laminates. There are a zillion puzzles, all leveled. I can say, I want 9 numbers for addition. I click on a Kakuma addition, and there you have a whole file of puzzles. You can laminate, put them in a sleeve, laminate it. The answers to the flip side are at the bottom. So again, now we can do math centers. So I've created a ton of games. So Kakuma is just one of them. My most recent game, because I know I'm out of time, is called Espresso. Turns out in the new state standards, order of operations is now a 3rd grade standard. Okay, so we got to get kids ready for order operations in 1st and 2nd grade with addition and subtraction. Then all 4 operations, 3rd grade and up. You go play games, you click on Espresso, it's all leveled for the kids. You click the materials section, all the materials are there. You click on Espresso, there's all right here, all the PDF files. Okay, so again, for me, the future of math is we develop better, more intuitive strategies. Then we take technology and apply it in a way that actually teaches kids how to look at numbers the right way, then gets them to practice, practice, practice. Now, if you look at Kakuma, what's the reward for solving the first 9 problems in a Kakuma puzzle? You get another puzzle at the end. So I'm not incenting kids to play by putting in non-math hooks. I'm making math the whole centerpiece of the game. Okay? So Tammy and I appreciate you taking the time to come. Thank you very much.
Can you switch back to my computer? Just the handout information again in case you missed it, Greg's website, and we'll also be hanging out at the SDE booth for the next hour and a half or so if you want to come visit with us there. So thank you all very much.